Hello everyone, good morning, good evening. In the last class, we have discussed about the tight coupling, and there we have seen couple of example, and there we try to understand how we can achieve the tight coupling, or how my class can be dependent on other class, and if my class is dependent on other class, how I can say this is the tightly coupled class. So we have seen this example yesterday and in the our last class session. Okay, and there we have discussed about how my class, this Dell, Lenovo, and this Acer was tightly coupled with this Intel M. So in this example, we understand if I'm creating the object of any class inside of any other class, then I can say that this class is the tightly coupled with this Intel M class. So you can see here, this in somehow inside the Dell class, I was creating the object for the Intel M, and the same thing I was doing for the Lenovo, and the same thing I was doing for the Acer. Acer, and then I can say that this Lenovo, Dell, and Acer was tightly coupled with the Intel M class. Now, what can be the challenge or what can be the problem I can face if my class can be the tightly coupled? So the first problem I can say, if your class will be the tightly coupled, then you have to always go with the maintenance activity. How we can say we have to go with the maintenance activity? So suppose this class in Lenovo and Acer all are dependent on the Intel M class. Now suppose in the future, suppose either this class is no more exist, like this class is no more available, or suppose this class has been deprecated, or this class is no more existence in our package. Or suppose we are going to rename this class. Instead of Intel, I am going to rename with this Microsoft Intel. Okay. So suppose I rename this class, and this can be possible. Okay, in the real time scenario, this can be the possible. Either the class can be deprecated, or the class will not be available after some time, or the class can be renamed with some other name. This can be possible. If I'm going to rename this class, then what will be the impact on Dell class? If you will do like this, if suppose there is no more Intel M class, or if there is no more Intel M class, then you can see we'll we'll start getting the compile time error for in each and every class. So suppose here Dell is there, Lenovo is there, and Acer is there. Now, if there is no more Intel M in our packages, we'll start getting the compile time error because of this line. Because I'm trying to create the object for the Intel M, and they will say, hey, the Intel M is no more available. And so do you want to create the class, or you want to remove this object? So somehow I'm going to get the compile time error. So if I will get the compile time error, somehow I have to fix this compile time error. So how I can fix? So since here I have three class, what I will do, instead of Intel M, I will replace this Intel M now with Microsoft Intel M. So I will go in each and every class, and I will replace this Intel M with Microsoft Intel M, and somehow I can able to resolve my compilation issue, or somehow I can able to fix the error which I will get in my class. So somehow here you can see I had three class, and we can easily able to change the class name, or we can able to change the object name if there was any changes with the class Intel M. Now, but suppose the second scenario, suppose there is one class, and suppose my class, suppose this Intel M class, suppose this Intel M class was dependent on the 100 classes. There is a chance my class, this class can be dependent on the 100 classes. When the name was Intel M, that time the dependency, this class was the tightly coupled with some other 100 classes in my project. Now, if I will rename this class, or if this class will not no longer available in my package, then all the 100 class which was tightly coupled with this Intel all will get impacted. And somehow to fix the error, or to resolve the compile time each error, somehow we have to go in each and every class, and we have to change this class object. We have to create the object again with the new class, and the new class was nothing the Microsoft Intel M. So somehow earlier the object with Intel M, now the new object which I am creating in every class with Microsoft Intel M. And this activity I have to do for all the 100 classes. And somehow this is a time taking process. And so if your class will be the tightly coupled with other class, you have to go with the maintenance activity, and sometime, or most of the time, we can say not sometime, most of the time, it will be the time taking process or time consuming process. So if you are going to develop any project, make sure you will not make your class as a tightly coupled class. Otherwise, you can face this kind of the problem. What can be the other problem we can face if my class is the tightly coupled? So other problem what I can face here. Suppose here you can see I have one method in my Dell class. The method name is my processor. So this is the one of method in my class inside the Dell. The name is my processor. Suppose I want to write the test case. I want to write the test case for this class. If I want to write the test case, somehow you can see here my method is dependent on some other method. Okay, or somehow you can see somehow my class is tightly coupled with some other class, and if I want to write the test case for this my processor, somehow I have to write the test case for provide processor as well. Until or unless I will not do the testing for this provide processor, I cannot say my processor function or my processor method will work fine. So if I mean to say, if I want to write the test case for my processor, somehow I have to write the test case for private processor, or somehow I have to test the private processor first, and then I will test my processor method as well. And then if everything will work fine, I can say that my processor will work fine. But suppose in my processor method, there is no problem, but due to the any reason, I'm getting some issue with private processor method, then I can say that my processor method will not work fine, or some of the test case is not getting passed for my processor method. So there was no problem with my method, but since my class was tightly coupled with this Microsoft Intel M, and somehow I was using their method, and since I have to test this method as well, but there's some problem with this test method. Some test cases getting fail. If the test case will get failure, somehow my test case will get fail for this method as well. Okay, and I can say that my method is not working fine, or and we can say that might be some test case is getting fail, and we have to fix that test case. In the real time scenario, we can just understand in such a way. Suppose Dell is supposed to introduce one new laptop in the market, and for the processor, they are dependent on the Intel company or Microsoft Intel company. Now, Microsoft Intel has given the processor. The processor is Droid processor. Now, Dell, before releasing the system in the market or deliver to their customer, they want to do the testing. They want to check this new processor which Intel has given to the Dell, is it compatible with the Dell new laptop or not? If yes, what is the performance? How what is the like is there any what is the performance? Is this will provide the good performance or not? Or is this super fast? Like is this going to give the good performance, or everything will every function is working fine or not? The Dell want to test each and everything first. So this since processor given by the Intel, Dell have tested their method. But since now Dell want to integrate this with processor, somehow they will do again one more round of the testing to check that everything is working fine or not. If suppose if this processor is not compatible with the Dell architecture, then you can say then Dell will say, hey, this is not suitable for the architecture of my system, and somehow I'm not going to use this processor. So somehow there is chance some Dell function was working fine, but because of this processor, there can be some issue, and because of that, they'll say I will not use this processor, or or there is some problem with this processor. Okay. The second scenario which I told, the first example which I was talking about the maintenance activity. Again, if I will talk in the real time scenario, so as you can see here, there is some company known as Intel or Microsoft Intel, and this company is responsible to provide the processor for each and every company like Dell, Lenovo, Acer, and many more. Now, suppose this company will be shut down. This company will be shut down. Then what will the impact on the Dell company? What will the impact on the Lenovo? What will be the impact on the Acer? Somehow this all the company business will get impacted badly. I mean to say, since for the processor, this all the company was dependent on the Intel. Now there is no Intel company. The Intel has been shut down. Now this Dell, Lenovo, and Acer, they cannot able to release the new system in the market because of the scarcity, or because of the processor. Now until unless they will not get the alternate option, or they will not get the processor from other service provider, they cannot able to deliver the laptop to their client, or they cannot able to deliver the new system in the market. And this all is happening because this Dell, Lenovo, Acer and other laptop or desktop company was tightly coupled with the Intel. I hope this is clear for you. So to avoid this scenario, okay, to avoid this scenario, like to avoid the maintenance activity, or to avoid the writing the test case, or to test the dependent object method as well, somehow we'll go for the loose coupling. Loose coupling means somehow, again, if I'm saying coupling means somehow my class will depend on the other class here as well. Okay. Even if I'm talking about the loose coupling, somehow my class will depend on other class as well. Loose coupling does not means my class will not dependent on other class. Somehow my class will dependent on other class as well. But somehow I'm not going to create the object of one class inside the another class. I mean to say I will not create the object like here. So I will make my dependent class as a loosely coupled, not as a tight couple. So how I can do that? For that, I'm going to introduce, or I'm going to make some design changes here. Instead of the class, I'm going to create the interface here. So what I will do, we have this class. You can see we have this class, and somehow I was creating the uh, method inside this class, and then somehow all this Dell, Lenovo, and other classes was dependent on this Microsoft Intel M, and somehow I was trying to call their method. Now what I'm going to do, I'm going to create one interface. So interface name, suppose what I will do, I will create the interface, and suppose I'm going to provide the interface name as a service provider. Okay. And now this interface has one method. The method name is nothing but provide processor. So now you can see here, I'm going to make the design change here. And this, since this is the interface, I'm not going to provide the implementation of this method. I'm just writing the signature public void provide processor. Now I will not, what I will do, this class will be as usual. This Microsoft Intel, I'm not going to make any changes here. Just what I will do, this class will be this class will implement the method of the implement the interface implement this service provider interface. So I'm saying implement service provider interface, and since this is going to implement this Microsoft Intel M, or let me write only Intel M, this Intel M somehow implement the service provider interface, and since this is the interface, somehow we have to override this method, and somehow we can see here I'm providing the implementation for this method. I'm providing the implementation for this method. Now what I will do, I will not make in I will copy this all other class as well. I will copy this all other class as well, and I will make very small changes here. I'll make very small changes here. So I'm going to copy all other class as well, and I'm going to make very small changes. So now what changes I'm going to do here? So you can see here, my class was totally dependent on this Intel M. Now I'm saying here I'm going to remove this class, and I'm going to remove this object. Now if I will remove this object, might be you can ask then how you will call this method. Are you going to remove this method as well? No, I am not going to remove this method. I will call this method. But to call this method now, what I will do, I will call on the reference of the parent class of the Intel M company. So now what I'm going to do, I'm going to create the reference of the service provider. And this is the child parent class for this is parent class for the Intel M company. So you can see here, I'm going to create the reference of this service provider, and might be I'm going to write the I1, or better I can write service one. Okay, service one reference variable. Just I'm creating this name can be anything. This can be the I1, service one, I2, any name you can provide here. You can write any name. Now what I'm going to do, the same activity I'm going to do for other class as well, or all the classes which was earlier dependent on the Intel M. Now I'm going to remove this and remove this object, and somehow I'm saying this, I'm going to create the reference variable of this interface. And the same here, since this is the service one, now I'm going to write the service two, and then on the service two, I will call this method. I will call this method. And just I'm going to copy this log statement as well, and I will write in each and every class as well, so that once I will run the program, we'll get to know from where this line is getting executed. So I can say no my processor. The method name is no my processor. I will pass here. I will override this, and then what I'm going to do, I'm here this class, this method is getting executed from the Lenovo class. So I'm just changing the machine, nothing else. Just a small changes I have done here. Okay, that's it. Now after that, I'm trying to call this method. I'm calling the service2.provide processor. So still you can see I'm calling the method in every class, but I'm just making a small change. Earlier I was trying to create the object for the Intel M or Microsoft Intel M. Now I'm changing this one. Now here again, I will create one reference variable of this interface as a service3. You can write the same name as well. There is no problem. Service2 also you can write. There is no problem. And then here I'm calling this method. Now, if you try to run, now suppose I'm going to create one more class here, and that is a main class. So I will create the main class as well. I will create the main class as well so that I can create the object and I can run this program. So as of now, you can see I don't have any main method in any of the class. Now I am going to create the final class, and that is the class test. Class test loose coupling. Loose coupling. Okay. Now here I am going to create the main method. So we can write public static. I will I will do one thing. I will run this example in the Eclipse. I will show you how we can run public static void main. And then I'm writing string args, and then what I'm going to do, I'm going to create the object. So suppose I will have to run this, I have to call this method my processor, or suppose you are going to call the method which is inside the Dell. What is the method we have inside the Dell? So inside Dell, the method name is my processor. Suppose I want to call this my processor. So how I can call this my processor? To call that my processor, somehow here I'm going to create the object for the Dell. Dell is equal to new Dell, and then I can say that on the defense of the Dell, now Dell dot method calling. So this line I'm going to do. Now, if you run this program, and once you'll call this my processor method, which is available inside this Dell method, which is available inside this Dell class, you are going to get the null pointer exception. Now anyone can guess why I will get the null pointer exception. So why you will get the null pointer exception? Let me explain you. You can see here, once I'm calling this method, there is no problem. They will print this line as well. They will print this line as well. There is no problem. But here, once I'm trying to call this method, you can see here this service1. This service1 is the reference variable, and somehow I'm not initializing or not instantiating this reference variable. I mean to say I'm not initializing, I'm not assigning inside this any value inside this service1. And since this is a global variable, and if you not assign any value, or if you not initialize this reference variable, somehow JVM is going to initialize. And if JVM will initialize any of the object or reference variable, it will initialize the default value as a null. Now somehow here you are trying to call this method provide processor on the null, and if you call any method on null, you will get the null pointer exception. Let me run this example on the Eclipse, and then we'll see how we can achieve the loose coupling. So somehow this is the half part of the loose coupling. Okay, still we have to discuss many more things. So you can see here, first thing, I'm not creating the object in any of the class. Now my Dell class, Lenovo class, and Acer class are dependent on some classes, but now I'm not creating the object of one class inside another class. Or somehow I can say that I'm not creating the object for this Intel M inside the Dell class, Lenovo class, and Acer class. But now what challenge I'm facing, I'm not able to call this method. So we'll see how I can able to call this method. So let me run this example first. So this is my Eclipse. What I will do, I will create one Java project. So I will click on new, and then Java project. In case of Java project, here I have to write, I will create one package. So I'm saying loose coupling example, loose coupling, loose coupling example 2, okay, or loose coupling example, and then just finish this. Now inside this, there will be a src folder. Inside this, you can create your class and create your package. So I'm going to create the package saying that com dot loose coupling, loose coupling example. Okay. Now provide the class. So I'm going to create the interface. So what is the interface name? You can copy from here. Now you can start copy from here to the Eclipse. So I'm going to copy this. Now let me copy this. Since this should be the interface, I will change this class to the interface. Now you can see this is the class. I'm going to change into the interface. Right, interface. Okay. So this is the interface. Now you can see I have one method here. Just copy this method from here to there. And that's it. Now what I will do, I will get the one class. The class name is Intel M, which will implement the service provider. So I'm going to quickly create this class as well. So we'll write class Intel M and just finish this. Now what you can do, you can copy from here to here. This entire things you can copy from here to here. So just close this. You can see here, there is no problem. There is no compilation error. Somehow I'm trying to implement the service provider and somehow I'm adding this method which was available inside this interface. Inside the interface, we have this method and somehow I'm trying to add here. Any problem? No, right? Now, what I'm going to do, I'm going to create the del m class. Okay, I'm going to create the class with name del m, not del. I'm going to create the class with name del m. Since I have already the class with del, I'm going to create the class with del m. In some other package, I have the class with name del. That is when I'm not going to create the same class name again. And then you can copy this as well. You can copy this as well. There is no problem. You can see there is no compilation error. This is working fine somehow. Okay. Now what I'm going to do, I'm going to copy the other example as well. I'm going to copy the Lenovo class as well. I will create one Lenovo class. Instead of even Lenovo, I will create Lenovo M here. So Lenovo M, and then what I'm going to do, I'm going to copy this example, this logic from here to this class. Okay, Control Shift F for the format. I press Control Shift F. If you want to format your class, you can press Control Shift F all together and your class will get formatted. This is the shortcut to format your class. Otherwise, select and then there is some option, but I'm going to use the shortcut. The shortcut is nothing but Control Shift M. Okay, now we have to create one more class. Not one class. I think we have to create two class. One is the SR and then finally we have to create one main class. So this is the SR class. Let me write here. Let me create the SR class as well. So this is the SR class. So I can say SRM and then finish. And then copy the logic from this notepad to our class. So from here, I am going to copy here. Control Shift F. And you can see here, as of now, I'm not creating object inside the Acer, inside the Dell, or inside the Lenovo for the Intel M. Somehow I have the reference variable, but for this also, for this reference variable as well, I'm not creating any object, or I'm not initializing here itself. Okay, so somehow this is the loosely coupled class. How I will explain you again. Okay, let me first run this example and then I will explain you a little bit more about the loose coupling. Then it will be more clear. So here I'm going to create the final class, that is a test loose coupling. And here somehow I'm going to copy this. I'm going to copy this. Now, once we'll run this program, as I said earlier, we'll get the runtime exception. So this is not del. This is the now del m. I'm creating the del m. Okay. Now here everything is done. Now what I'm going to do, I'm going to run this class. So you can see here, this is the del m. What I can do here, I will open the del m here. Okay, I will open the del m in the right side window. So you can see here del m. Now once I will call this method, it will come here and it will print this message once I will run the program. And after printing this message, we'll get the null pointer exception. Let me run and let me show you this. So I'm going to run this example. You can run as Java application. And we can see here my processor. If you will want, let me make this bigger. So you can see here this message, this my processor method is getting called from del class. This message, the highlighted message is getting printed from this class, from the del m class. And then I'm getting the null pointer exception. And why I'm getting the null pointer exception? Because somehow I want to call this method and I'm trying to call this method on the service one, and somehow I'm not initializing this one. Since this is getting initialized by JVM, and if JVM is initializing this variable, then the value of this variable will be null, or the value assign inside this variable will be null, and if you'll call any method on the null, or if you'll perform any operation on the null, you will get the null pointer exception, and because of that reason I'm getting the null pointer exception. So now the question is that then how I can able to call this method. So now I can say that there are two ways to achieve the loose coupling in Java. And even the same way I can see in the Spring as well. So now if I want to call this method, somehow I have to initialize this variable. If I want to call this method, somehow I have to initialize this method, or somehow I have to create the object. Then how I can create the object? So I can say new and then intel m. So we can do that, and then if you run this program, you will not get the runtime error. But again, the problem will be again somehow I'm creating the object here, and somehow I have to avoid that. Since I have to avoid that, I cannot able to create the object with new keyword inside the my del m class or any of my classes. Now the question is then how I can initialize this variable. The one option you are rejecting, you are saying I will not create the object using the new keyword. Then what is the option do you have right now? I'm saying in Java, okay, since I'm going to achieve the loose coupling, there are a couple of ways and by which we can achieve the loose coupling, So what is the way we have? The first way I can say either you can achieve the loose coupling by the setter method or by the constructor. So we can achieve the loose coupling. We can achieve the loose coupling either by in two way. There are two way to it, or we can write like there are two way. There are two way to achieve the loose coupling in Java. We'll see how we can achieve in Spring later. But now I'm right. This project is, or this example is totally based on the core Java. There's no Spring concept. There is no Spring Boot concept. So how I can do that? So first I'm saying using the setter method. We'll go with setter method, or the second option I can say we'll go with constructor. What does it mean? Okay. So I'm going to constructor. So this set using the setter method. Okay. Somehow I will inject the dependency. CUNSTRUCTR. Okay. Constructor. So somehow, since this was the dependent object and I have to initialize this dependent object, so to inject this dependency or to initialize the dependency, either I will go with setter method or I will go with constructor. So for this class, I'm going to create the constructor. So how I can create the constructor? So I have to create the constructor using this data member. So what I will do, either I will write manually, or even we have option, I will go to the source and then I will come to this option here, and you can see here we have option generate constructor using field. I'm going to click on this and then I will select all, and then I will generate the constructor. Now you can see the constructor has been generated here. Now the constructor has been generated here. I'm getting some compilation error. Okay, so compilation error I'm getting the main class, that will fine. Okay, we'll resolve that later. But somehow what I have done here, I created one constructor for this delm class. And why I create the constructor? Because somehow I want to inject the dependency of this service one, or somehow I want to initialize this service one a reference variable. So how I want to initialize now? I said I can initialize this service one reference variable using the constructor. Now here you can see I'm getting the error because now we don't have the non-parameterized constructor. So I cannot create the object using the non-parameterized constructor. So somehow I have to create the object. We have to pass this reference variable here. I mean to say, while creating the object, somehow now I need the service provider object. So what I can do to create the service, to provide the service provider object inside the del m constructor, I'm going to create the object for the service provider. Or somehow I'm going to initialize I'm going to create the reference variable for the service provider interface, and I'm saying service. So I'm saying service here, or you can say provider or anything. Service only. I'm saying service is equal to this is the parent class for the Intel M. We know that this is the, you can see here this Intel M is the child class for super provider, service provider. And we know that from the rule of Java, a parent class reference variable can hold the object of the child class. So somehow I want to initialize this reference variable from the child class object. So what is the child class here for this service provider? That is the Intel M. So I'm going to create the object for the Intel M here. So earlier I was creating this Intel M object inside every class, inside the Dell class, inside the Lenovo class, inside the Intel M class. Sorry, inside the Acer class. Now here I'm creating this object in only one place, and that is the main class, or uh, inside the main method only. Okay. Now what I will do, I will pass this reference variable from here to here. So now once I will call this constructor, what they will do, they will come here and they will initialize this reference variable. And once this reference variable will get initialized, somehow this reference variable will also get initialized. Now this is no more null. And since this is not null, now we can easily able to call this method without any error. So now if I will call this method, what it will do, it will go to their implementation. And whatever the message I'm writing here, this message will get printed. This message will get printed. Let me run this example and let me show you. Just save this. There will be no compilation error. Just save this. Now run this program. You can see there is no compile time error. My example is compilation free. And you can see here I am able to call, or I'm able to print the message without any compilation issue and without any runtime error. So there is no compile time error, there is no runtime error, and I'm able to call my method successfully. And you can notice here, I'm not creating the object inside the Dell M. Even I will not create the object here in the Lenovo M. So I will not create the object anywhere. Now might will ask, okay, I want to call this method. What I can do? I'm saying, okay, just now I told you we can go with to inject the dependency, we can use the constructor injection, or we can use the constructor. Same as you can apply here. You can also create the constructor here as well. So how we can create the constructor? Right click, go to source, and then select the generate constructor using field, and then click on the generate. Once you will do this, the one constructor will get created with the data member whatever you have in your class. Now for this also, what I will do, I will come to here. Okay, and here also what I will do, let me format this class. Control Shift F, press Control Shift F for the format. Now what I'm going to do, I'm going to create the object for the Lenovo. So Lenovo M, L is equal to Lenovo M, is equal to Lenovo M. And here for Lenovo M also, we have to provide the reference variable of the service provider. And I have here the reference variable. I'm passing this. Now what I will do, I will call the method which is available inside the Lenovo M, and the method name is nothing but know my processor. So now I'm going to call this without any error. And once I will run this program, now know my processor method will also get called. And if this will get called, even this message will print successfully. And after printing this message again, you will able to see the same message. It will repeat. So let me run again the main class and we'll see what is the output here. Run as, then Java application. And then you can see here, somehow this message also getting printed. This message and this message, one from the Dell class, another from the Lenovo class, and then somehow I'm able to call the Intel M method as well without any problem. Now at least we understand, okay, this is the one way by which we can inject the dependency, or we can initialize this reference variable inside any of the class. So if my class is dependent on any other class, what I will do, first I will go with the interface concept. I will go with the interface concept, and second, I will create the reference of the interface, not of the class. And the third thing, I will not create the object inside of a Dell M, Lenovo M, or Acer M, or any of the classes. Just I will create the reference variable, and to initialize the reference variable, I will use the constructor. So using constructor, I am trying to initialize this one. Now the second way, as I mentioned here, the second way is the setter method, and using the setter method also, you can able to initialize the reference variable. So how I can do that? So come to the Acer class now. What I will do, I will go to the Acer class here. I will open this Acer class. Let me open in the right side window. So I will close from here, and suppose I'm going to open in the right side window. So you can see here we have the service 3. Now I want to initialize this. How I can initialize? One way is the constructor. The second way, I want to go with second way. What is the second way? Second way is the setter method. So I have to create the setter method for this data member. To create the setter method, again you have to go to the source. Then again you have to come to here, and you can see generate setter and getter option is available. If I want to just generate the setter, not the getter, so I will select the option, select setter, and then I will click on generate. Somehow the setter method will get generated. Now the question is how I can inject this one. How I can call this method? So what I will do, first I will create the object for the SRM. Okay. First I am going to create the object for the SRM. Okay. So to create the object inside the main class, I'm writing SRM, SR is equal to new SRM. So somehow I'm going to create the object. Here you can see I'm able to create the object using without the with a non-parameterized constructor, because here I don't have any constructor, and if you don't have any constructor, then JVM, then Java or JVM is responsible to provide the default constructor. And somehow here I'm creating the object using the default constructor or non-parameterized constructor. Now, before calling this method, somehow I have to call this method. Why I have to call this method? Because until unless I will not call this method, this reference variable is not going to initialize. So before calling this method, first of all, I have to call the setter method. So somehow I'm going to call the setter method. So what I will do, I will write SR dot, oh, spelling typo mistake. So SR dot, you can see here, I'm going to call the set service. I'm calling this set service method, and I'm passing the reference of the service provider interface. I'm providing the reference of the service provider class. Now, since this method will get called, set service 3 method is getting called, and somehow I'm initializing this reference variable, and somehow using this value, I'm trying to initialize this reference variable as well. And after initializing this reference variable, once I will call this method, this message will get print, and after printing this message, again, they will try to call this method, and now we can able to call this method without any problem, without any error. I can able to call this method as well. So the one way to achieve the loose coupling as a constructor, the second way to achieve the loose coupling via setter method. So you can go with any approach. I don't have any, we will not get any problem, or it does not matter how I'm injecting the dependency. I'm injecting or achieving the loose coupling via setter or via constructor, it does not matters. But there are two ways to achieve the loose coupling, either via the setter method or via the constructor. Now I'm writing SR dot, I'm trying to call the method. What is the method I have? My processor. So I'm calling this one. Now you can try to run this example. You will not get any issue, and this program will run fine without any error. And somehow I'm able to call each and every method without any problem. Without any problem, I can able to run this example. So first thing you can observe here, inside the Acer, inside the Dell, inside the Lenovo. Earlier, I was trying to create the object. Now using the new keyword. Now are you creating any object using the new keyword of any of the class inside the Dell, inside the Acer, or inside the Lenovo? No, right? Since I'm not creating the object, somehow I can say my class is loosely coupled, not tightly coupled. This my class is not tightly coupled. Now might be the question can come in your mind. Okay, suppose as you said in the tight coupling, if this class is no more available, or if this class is getting renamed with some other class, I'm saying change this class with some other name. Tell me with what name you want to change. I want to change with Microsoft. So okay, I'm saying Microsoft Intel M. This is the class name. Now since this class, since I want to replace the Intel M with Microsoft Intel M, I can say you can replace that. So if I'll change this name, if I will replace the Intel M with Microsoft Intel M, do you think there will be any impact on Acer, Dell, and Lenovo? No, there will be no impact at all. Let me rename this. So now I don't have any Intel M in my package. I have Microsoft Intel M. Are you able to see there is any impact on the Acer? Are you able to see is there any impact on the Dell M? Are you able to see there is any impact on the Lenovo? There is no impact on any of the dependent class. Why? Because somehow I was not creating the reference of the class. I was creating the reference of the interface. The class name has been renamed, or the class is no longer available, or the class has been acquired, has been changed with some other name. Or in any of the scenario, I'm not my Lenovo class, my Dell class, or my Acer class, or all other class is not going to impact it. Now only one class is going to impact, and that is the nothing but the main class. And somehow changing the value on multiple place, instead of that changing the value in one place, somehow it will be easy solution. So now I will change this Intel M with Microsoft Intel M, and now you can see the issue has been resolved, and somehow again if you run this program, it will run without any problem. So it does not matter with what class name here we have, even it is there or its name it's getting changed, there will be no impact of this changes on my any of the dependent class. Like there will be no impact on my Acer class, there will be no impact on my Dell class, there will be no impact on my Lenovo class. Not, no class is going to impact. Only one class is going to impact, that's the main class, and some of very, very small changes we can quickly do. And so this is the way to achieve the loose coupling. Either you can go via the setter method or you can go via the constructor. So this is the two way to achieve the loose coupling in Java. In next class, we'll see how we can achieve the loose coupling in the Spring, and we try to understand there what is the IOC, what is the DI. So we'll see you in the next class. I'm going to close the class for today.